Welcome to today's workshop, which we are calling Destroying Long-Lived Cloud Credentials with Workload Identity Federation. It's a mouthful to say. Ultimately, what we're going to be up to today is we've got an open source repository that you're going to fork into your own GitHub organization, and we're going to deploy an architecture that allows you to authenticate cross-cloud from Azure to AWS and into Google Cloud. And you're going to be able to set all of that up in your own accounts, and you're going to be able to test out the different ways that we can authenticate with long-lived credentials as well as with Workload Identity Federation. I won't be presenting a ton of material today. It's going to be mostly hands-on with you walking through some instructions that are available in our GitHub docs. Before we jump in, and I'll show you where those resources are, a couple of administrative items. First of all, if I haven't had a chance to meet you in person or virtually in the past, my name's Eric Johnson. I'm a principal security engineer with Puma Security, and I spend a lot of my time working inside of the clouds, inside of AWS, Azure, and Google. All of them, I'd say I am pretty fluent with at this point after spending the last several years working in those ecosystems with small to medium-sized businesses to help audit those environments, to help build them, to help enable security controls, build least privileged IAM. We do a lot of work with CI/CD orchestration and running security tooling, and also aggregating that data into dashboards and trying to build out some automated compliance for folks. At SANS, I've been around for over 10 years now. I started out teaching our application security courses, which is the secure coding in .NET and Java courses, which are no longer in the catalog. And over time, those concepts largely got pulled into Sec 540, which is all about DevSecOps and cloud security automation. I've also had the pleasure of working with Brandon Evans on building Sec 510, which is all about public cloud security and misconfigurations across the three cloud providers. And recently with Kat Traxler helping build Sec 549, which is enterprise cloud security architecture. So all of these courses will come into play today, actually, as we put this system together. We've got a little bit of 540 in a GitHub repository and a GitHub Action that you're going to be able to use and run. A little bit of Sec 510 with cross-cloud and multi-cloud authentication, and a little bit of Sec 549, which is more identity architecture. So you're going to get a feel for what we would go through in a lot of these courses. And I think the material will be very useful for you in real life as you start on your journey towards destroying or getting rid of long-lived credentials and using OpenID Connect to authenticate workloads cross-cloud to each other. If you need to reach out to me post-workshop, the Discord channel, which I'll get you a link to here in a moment, is going to be the best place to do that. I know my colleague, Eric Mead, is also on the discussion and also in the workshop channel as well. So both of us work at Puma Security, and we'll be keeping an eye on it if you have trouble tearing the environment down or run into problems, post-workshop, which we're going to cap at 2 hours today. You can also reach out on LinkedIn or on Twitter, but the Discord channel is definitely the way to go for getting more real-time answers to things. So our agenda today, we're going to go through a getting started section first, which is probably going to be, I would say, the most challenging piece, which is really getting the architecture up off the ground. You've got to bootstrap all of your environments and 3 secrets inside of your GitHub repository that you're going to fork here momentarily. So we'll take a nice 30-minute break and let you work through that, and then I'll cover it at a high level. And then we'll get into exploring how that deployment put long-lived credentials in each of the cloud providers. So you're going to end up with a set of Azure Service Principal client IDs and secrets in a GitHub secret. And then you're going to end up with AWS creds and Google creds on an Azure virtual machine, which you can connect to and use. And once we've explored that, we will then move into setting up identity federation between Azure, AWS, and Google. You'll get a chance to see the difference between those, and you'll get a chance to use them from the command line. We'll actually authenticate from Azure to AWS and to Google without needing those long-lived credentials. So that's the agenda here for the next couple of hours. In order to interact with everyone, and if you have questions or if you need help or get stuck somewhere, join the Sans Cloud Ace Discord workspace. That link is at sansurl.com/cloud-discord. So go to that link, sign into the Discord workspace using, I would suggest, a personal email address, because if you use a work address or something, it's possible you might lose access or get locked out. And then once you're in there, find the workshop discussions channel. In that workshop discussions channel, I posted a message with the links on the next slide in there already. So if you see that, you're in the right place and you're ready to get started. So what we're deploying is an open source repository that Eric and I named Nymeria. And Nymeria, the play there is it's a three-headed wolf, and there might be a subtle reference to Game of Thrones there as well. But the colors in the wolf logo are representing Azure and AWS and Google. And the idea here is that you can communicate a workload in one of them to a workload in the other two just by using OpenID Connect and Workload Identity Federation. So go out to github.com/pumasecurity/Nymeria. That's where the repository is. And there's also links and a YouTube video to an RSA talk that I did, I think it was last April, related to this project where I introduced it for the very first time. So you'll need to have that GitHub repo up in one browser tab, and then in another tab, open up the actual workshop instructions, which are at pumasecurity.github.io/Nymeria. That has step-by-step instructions through each step of our agenda today, including the getting started, which is where I want you to jump into now if you have completed the prerequisites that went out in the email before we started. So go ahead and start taking a look at those instructions. And what I'm going to do is I'll put a timer on the screen here for the next 30 minutes. And overall, in the getting started section, if you're ready to get going, if you've met the prereqs and you're signed into your AWS account, your Azure subscription, and your Google Cloud project, and your GitHub account, you can go ahead and fork the Nymeria repository into your own personal GitHub account. And then you can open a Cloud Shell in Azure and in AWS and in Google, and you're going to clone that repo into your Cloud Shell, deploy some Terraform resources, take the output from Terraform and put them into a GitHub Action secret. And when all that's done, you should be able to run a federated identity GitHub action that will deploy the rest of the architecture out to your cloud environment in Azure. And then we're ready to start exploring. So spend the next 30 minutes on this, and then I will lightly walk through where things should be at when the timer expires, and then we'll talk about what the next step is. If you have questions or get stuck, feel free to reach out inside of the Discord workshop discussions channel, and we'll catch you here in a little bit. Hey, folks, let's pause here for a moment, and I will give you the high level of what we did during the getting started section, and I'll walk you through a couple of the steps and where those cloud shells live, and hopefully that'll help illustrate what we're trying to accomplish and give you some clarity on moving forward into the next sections. So as we take a peek at getting started, the overall architecture, I'll show you the GitHub repository and what my forked version looks like here in a moment. But overall, you've got this GitHub repository in your own personal account now, and that's got a GitHub action associated with it that is going to deploy the architecture that you're seeing on the slide here. The way that this works is the GitHub action is authenticating to Azure using an Azure app registration, which is basically a way to obtain permissions for a service principal in your intra ID tenant is the new name for it that formerly was known as the Azure Active Directory tenant. That particular Active Directory object or user has permissions to manage a service account or a resource group in Azure, which we call the Nymeria workshop. And inside of that resource group, it's going to create a virtual machine. and then deploy some files out to that virtual machine that we'll use here in the next section as we take a look at the long-lived credentials that were deployed. Those long-lived credentials belong to an AWS account and a Google Cloud project. And inside of those accounts are one storage bucket, essentially, for each provider. So you've got an S3 bucket in AWS with one file in it, and you've got a Google Cloud storage bucket in your GCP project with one file in it. And the goal is from the Azure VM is going to be to download that file from AWS and from Google onto the virtual machine that's running in Azure. That is going to require you to authenticate to the AWS APIs and the Google Cloud APIs. And of course, we're going to explore two different ways that you can do that. One using long-lived credentials and one using OpenID Connect Identity Federation. So as we take a look, I'll show you at least the browser setup here. So let me first go to GitHub. And what you should have done, this is my GitHub account. And if I go to the Puma Security org, you should have been able to browse out here and use this fork button to create your own copy of our Nymeria repo inside of your personal GitHub account. So that was step one, is you needed to fork that into your own repository. When you do that, mine's eJohn20, and all of you should have your own personal username there. You now have the ability to clone this repository into your own org and make changes to it if you want to. So as you take a look at the code here, and we look at cloning that, I wanted you to copy the clone URL, which is the HTTPS URL, and that's what you were going to clone into the Cloud Shell in each cloud provider in order to deploy the various pieces of this. So you started out with Azure, and there's a little terminal icon up here where you can open the Azure Cloud Shell, and that's going to create a little storage account in your Azure subscription so you can actually store files in here long-term past this session. And once that's done, you've got a cloud drive mounted in here. And if you change into the cloud drive directory and do another ls on that, you'll notice you should have a directory called Nymeria that was created when you ran the git clone and you pasted in that clone HTTPS URL. And then I had you change into the first bootstrap, which is in source, workshop, and then 01 is the Azure init sequence. And you ran a Terraform set of commands in here to deploy some resources to Azure. And then I had you run the Terraform output --JSON command to pull all of the outputs from that Terraform deployment and put them in a GitHub Actions secret. So if we go back to our GitHub project, once that was all done, and you go to the settings of the repository, and you take a look at the secrets and the variables, go to Actions, the output from Azure, you should have put into a secret called Azure Bootstrap, and you paste that entire JSON output from the Terraform output command into the secret and hit save. Then you did the same thing in AWS using their Cloud Shell. So this is what their Cloud Shell will look like. Open up Cloud Shell again. So this will load up a Cloud Shell inside of AWS for us. And once that terminal is ready, same thing, we zoom in on this just a little bit so you can see it. We ls here, you'll notice I've got, again, Nymeria directory, and in this case, we're going to source workshop 02 AWS init, run the same Terraform commands, grab the output from that, and put that in the AWS Bootstrap. As we take a look at the Google Cloud version of this, we're going to play the same game here. Zoom in on this a little bit so you can see it. We're going to clone that Nymeria repo, and you should be able to change into that source 03, workshop 03, and deploy that, grab the output, and finally, you can put that in the GCP Bootstrap secret. So with all three of those ready, what you then did is you went to the Actions, Federated Identity, and you used the Run Workflow button, and you hit Run Workflow right here, and that will deploy your Federated Identity configuration out into Azure. Now, this is where you could have run into a couple of hiccups. If the JSON output was not copied and pasted correctly from each of those steps in the Cloud Shell, you could run into an error here. So if you hit an error there, make sure you go back and double check that that output is correct. Also, your Azure subscription needs to be able to launch a virtual machine for this to complete successfully. If you're in a brand new Azure subscription, it's possible that your account is not quite warmed up or has been provisioned the ability to launch instances, which does happen in some brand new Azure subscriptions. So if that is the case, what I would recommend, and if we kind of just dig into the code here for just a moment, I'll show you where the VM type is actually being selected. If you go to the 04 GitHub Action, which is what we're running there, there's a variable here called the virtual machine SKU, and that's trying to launch an A2 version 2 VM into your Azure subscription. If you hit an error where you can't create the VM, what I would recommend is go into the Azure Web Console and manually create an A2 V2 virtual machine from the web console, and that should auto provision you the resources that you need to turn the APIs on and get some capacity in the East US location. So make sure you pick East US for that. Alternatively, you can set these two TF vars to a different location and a different SKU to launch that piece. So those are just a couple of troubleshooting steps if you happen to run into an error when you hit that part. So with that, you should have seen, hopefully, a green output on the federated identity step, which tells us that we created a number of different resources in your Azure subscription. So if we look at the output from the Run Terraform job, you'll notice that you've got a Linux virtual machine that was created, which we'll connect to in the next step, as well as a network interface with a public IP on it. And then we'll push some of those resources with the long-lived credentials and the workload identity configuration out to that VM. So if everything's green there, you're ready to move on to the next step, which is exploring how the long-lived credentials are working. So just to let you know, in this first step here, where I say steal the long-lived credentials from the GitHub Action, if you choose to do that part, you are momentarily exposing service principal secrets publicly. They're going to be available in your GitHub Action outputs. Now, those service principal permissions are fairly restricted. They've only got read access on the resource group. So there's nothing really damaging that can happen to your particular account based on those service principal secrets being leaked, but just be aware that is going to happen if you choose to do that step. If you don't want to do that step, you can skip it. It's not required. And you can SSH to the VM, and you can test the AWS and Google versions without leaking anything publicly. In the first step, if you choose to do it, make sure you follow it all the way to the end, because it will have you immediately delete the client secret values, so those secrets are worthless, and it will have you delete the GitHub Action log that contains those secrets. So just be aware there will be a short exposure window where you will have exposed a credential, and we'll have you clean that up. So spend the next 30 minutes working on this part, and then we will circle back and I'll kind of walk through what that would have looked like a little bit. If you've got questions or if you have anything you want to chat about in detail, jump in and throw that into the Discord workspace, the workshop discussions channel, and we can start chatting in there, or we can go in and maybe help do some troubleshooting or anything like that that comes out. So that's where we're kind of taking a look for questions and whatnot. Enjoy the long live credentials section. This is the way that everybody kind of does this by default. And once you understand what that looks like, we'll switch over to no long live credentials for the rest of the workshop after. All right, we'll catch you back here in a little bit. All right, welcome back from the long live credentials exploration activity. A couple of comments came up as we went through that section in the Discord workspace. Ben asked, which is always an interesting scenario to explore, is okay, after leaking these credentials in the GitHub Action, how long does it take for either Azure or GitHub to notify us? And I don't have good news there. I've never actually been notified that I did this by either GitHub or by Azure. Perhaps it's because it's only been for a few minutes, and maybe it's because the roles are relatively strict, but I don't think that should matter overall. So hopefully someone at Azure or GitHub will see this at some point and say, hey, maybe we should be looking in our log files for these sorts of things and at least notify the customer that this has happened. I'll show you where that is here momentarily. And then another question came in, just deploying the federated identity workflow. In the previous section, there was an error about not being able to register the Azure's web provider or the compute provider. Your service principal does not have access to do that. So that is something that you'll need to do during the setup of your account. So what I did is I just updated the prerequisites to have you run those couple of commands as you bootstrap your Azure account. And then hopefully that will resolve itself. But if you get some sort of an authorization failed registering a provider, that's just because you're in a brand new Azure subscription. It hasn't been used. If you run those commands and wait a few minutes, it should take care of it. Also, just I think creating a virtual machine manually would kind of automatically run those commands for you under the hood and get you to the point where you can jump into the long-lived credentials section. So we're running a little tight on time here because we've got a couple of sections left. So I'll do a light walkthrough on this one. I'm not going to run all the commands for you, but I'll at least show you how things should look when you jump in here. As you switch over to GitHub, once you get into this part of the workflow, I had you go into a long-lived credentials GitHub action and use the run workflow button on the main branch. I put a warning here that said, hey, for the record, you're about to dump a secret out to your log files, and you've got to say, hey, yes, I understand, run the workflow. I'm trying to stop you from making a mistake if you're not comfortable doing that. As you dig into it and you go to the apply Terraform output, where you're going to see is the Azure login action. This is where GitHub is authenticating to Azure, is going to be authenticating using a legacy mechanism at this point. There's even a warning that says, hey, Eric, this also supports OIDC for login. Maybe you should read about how to do that instead of doing what you're doing, which is using a static long-lived credential. And if you expand this little run block here, you're going to see the creds that I provided are output in the logs right here. And this is really what GitHub should be looking for. They ought to be seeing this and sending you an email that says you probably need to be at least masking those values, if at all possible. And there are ways to do that. And I'll show you where that is in the federated workflow here in a little bit. But for now, credentials have been leaked. And that's all you really need to know. If you steal these, you can jump over to any terminal and use them. So I had you go into the terminal for your Azure account and just ran the AD sign in user show command. And you can see I'm logged in as Eric Johnson, which is not the service principal. And then I exported those 4 values into environment variables and ran the AZ login command again, which is going to log me in with those stolen creds. And as you go down, you can see that I was authenticated successfully. And here is the Nymeria workshop resource group that I've got access to read from those credentials. So that's the pivoting aspect to using those. If they had more permissions, that could be really bad for your organization. And we want to get rid of those. So in order to do that, let's clean this up real quick. Make sure you do this, as I'm going to restart the Cloud shell, because right now I'm authenticated with that service principal. And what I want to do is delete that client secret here before we forget about it. So as you restart the Cloud shell, reboot this thing here. Let's see if I can. There we go. So that's re-logging me in as my Eric E. Johnson user. Now that I'm in here, just run the commands from the instructions to grab that app ID. And we're just going to straight up delete that Azure AD application from Active Directory. So that's gone. The service principal credentials are no longer useful because there's nothing to authenticate with against the backend. The other thing you can do is also go back to your long-lived credentials action, and you can just use the delete button here to delete that workflow run, and that'll get rid of those creds from your public repository. So you've kind of minimized the damage there, contained that particular incident before you move forward. The next thing I wanted you to be able to do, and I've got my FQDN here in a file locally, but by CD into Cloud shell, and I'm just going to source the grab, I think I called it Git. And if I echo the Nymeria FQDN now, you'll see that that's my public VM. Yours is all going to be a little bit different with a different ID there. But the idea here is I want you to SSH out to that virtual machine. So if you run an SSH command, I had you pull that PIM file down from the Terraform outputs first. You should get to the point where you're on the VM. And as part of that federated deployment, what I did is I actually preloaded some long-lived credentials for AWS and for Azure on there. And if you cat the AWS credentials file, you're going to notice you've got some credentials there long-lived for authenticating from Azure into AWS. And you can use that by setting the profile and following those commands to pull an object from S3. Similarly, if you cat the .config gcloud directory, we've got some files in here that you can use to access Google specifically. So if we go in here and let's see here, where is that? Let me ls it, ls config gcloud. We've got a cross-cloud credential file as well as a cross-cloud key.json. So we're going to cat the cross-cloud key.json file, and that's going to be your private key for accessing the Google Cloud APIs. Again, a long-lived credential that we're going to get rid of as we push forward in the workshop. And use the instructions there. They will walk you through authenticating with those and downloading that object. But just to save a little bit of time, I'm not going to go through each of those steps for you, just step by step. So use the instructions that are out there in that workbook. So overall, the short story here is that we had a long-lived Azure client secret, long-lived access keys, and long-lived service account keys in order to authenticate each of these services to the other ones. The last couple of sections here, which I am going to compress time-wise a little bit, just so we can try to get you out of here by the top of the hour, is I want you to go review the Azure Federation setup, the AWS Federation, and the Google Cloud Federation setup in each cloud in order to see how we could do this without any of those long-lived credentials. So go ahead and move into the Azure Federation section. This one is much shorter as you're doing one cloud here in each of the environments. So I think what I'm going to do, just to try to give us enough time here to wrap up by the top of the hour, is give you roughly, we'll just say about 7 minutes per cloud to go through that configuration. And then we'll stop and take a look at it. And obviously, once the workshop wraps up, you're free to keep going and finish things off. So we'll catch you back here in a few minutes and we'll talk about the Azure Federation workflow. All right, let's take a quick look at the Azure Federation workflow here, just to illustrate what that was doing. We are shifting our focus over to the federated identity workflow that you ran during that getting started phase and how that was authenticating to your Azure subscription. what you did and two of the variables that you set on that Terraform deployment was the name of your GitHub username or your organization, and then the name of the repository, which was Nymeria. So what's happening there when you set those two variables is that that bootstrap deployment set up an Azure app registration that trusts your GitHub organization and your Nymeria repository, as well as the branch that that action is running on, which is main by default. So what's happening is that that GitHub action is communicating with GitHub's OpenID Connect provider, and it is requesting a JSON web token that's going to be scoped to your org, your repository in the branch, and we're going to use that to federate in to Azure in order to build the virtual machine and the other resources that were in there. So the first thing I had you do, if we go back to the federated identity workflow and open that up, is we go back into that Azure login step. In the Azure login step, you can see here it's telling us we're using OpenID Connect authentication. The issuer of the token is tokens action GitHub user content.com. And the subject is repo : and this is going to be your username, Nymeria, and then the refs section here really just describes which branch is this running on. That's going to be the exact value of the subject that's in the token that we send over. If we open this up a little bit, you'll also see that we have an audience set to API : / Azure AD token exchange, which is the default audience used by this GitHub action. You need all of those pieces of information in order to set up trust in Azure to this particular GitHub action. So let's switch over to Azure, and I'm going to minimize this Cloud Shell a little bit. And what you're looking for here is now the Intra ID service, which is in Microsoft's cloud, and that's going to be the actual old version of kind of Microsoft Active Directory. And you want to go to the app registrations. And if we look in here for Nymeria, let me go ahead and find the name of that thing, or it's called GitHub Federation, actually. So if you search in here for GitHub, you should see, let me scroll down a little bit. I might just kill this Cloud Shell so I can see it. And we'll look for the GitHub Federated AD app is going to be the name of that. That was created on 10/4. So yeah, that's when I deployed this. We're going to open up this app registration. And what you're looking for along the left-hand side is the certificates in the secrets section. And you'll notice we've got no client secrets here, which is what we exploited in the previous section. Instead, we're using a federated credential called GitHub Federation, which we can open up. And what you'll notice is that the issuer is set to tokens actions GitHub user content.com. We're saying any tokens from that issuer. The organization is my GitHub repo, the repository is Nymeria, and the branch is main, which translates to the exact subject that we saw inside of our GitHub Action workflow. And then we've got the exact audience that was there as well. If all of those fields match, and the token has those attributes, and the token is signed by a valid private key owned by that issuer, and when we get the token, what Azure will do is they'll validate the signature using the public key for that issuer. Then we can trust that this token is allowed to authenticate to Azure Active Directory and run that deployment. So that's the setup on the Azure side to get rid of those long-lived client secrets. Next up, go explore the AWS Identity Federation configuration. You're going to SSH back to that Azure virtual machine and look at the Managed Identities OpenID Connect token that's in the instance metadata service and how we can use that to authenticate to AWS to download that object from S3. So following the previous section, I'll put just a few minutes on the clock here, and then we'll come back and take a look at how that works. All right, let's take a look at AWS Identity Federation and how this was working. As we take a look at the way that your Azure virtual machine is authenticating to AWS, the most important piece here to understand is that the instance metadata service in Azure supports natively generating a JSON web token that is signed by your Azure Active Directory tenant. So all we really need to do is request a JWT that is scoped to our Azure virtual machine and tell it which audience it needs to have in it. And that's going to allow us to federate in and assume a role inside of the AWS account that has permissions to read the object from S3. So as we look at how that works, I'm going to go back to my Azure subscription and open up the Cloud Shell here. So the first thing I'm going to do is make a request. This is to the instance metadata service, this 169.254 address. And I'm requesting a token with an audience set to API://Nymeria workshop. And if I decode that token, which I ran a little JQ command here to decode this thing, I'll see exactly who the issuer is, which is my Azure Active Directory tenant inside of stswindows.net. I can see the audience is API://Nymeria workshop. And I have a unique subject identifier, the SUB claim, that uniquely identifies the managed identity assigned to the Nymeria virtual machine. And all you need to set this up in AWS are those three values. So as we change over to AWS, I want you to go to the IAM service and take a look at the identity providers that are in there. You'll notice you got one for sts.windows.net, and that, my friends, is the issuer. The next piece was the audience, which is API Nymeria workshop. So now tokens from that issuer with this audience are allowed to authenticate to this particular identity provider. The next piece that we had is a role called the Nymeria Azure VM role. And if we take a look at the trust relationship on this role, this is going to restrict access to the role to any principals that authenticate through that identity provider, through the assume role with web identity action. And we're going to also restrict the subject. This is really important because we want to make sure that only the Azure virtual machine, which is that subclaim, can actually assume this role. If you forget to add this condition in here, that opens it up so any principal inside of that Azure tenant can assume this role, which is probably not exactly what you want. So those are really important there. All three of those values are being set up and validated. So we can then take that token and assume the role from the Azure VM. And you're seeing that here when I run AWS STS assume role with web identity. I'm going to get temporary access keys back. And I ran the get caller identity command so I can see that I am actually authenticated as that IAM role now on the VM using that JSON web token. And then you can talk to S3 and pull that object down. So that's the Azure Virtual Machine to AWS Identity Federation workflow. We've got one section left in the workshop, which is doing the same sort of exploration from Azure into Google. So I'm going to give you just a few minutes again to continue exploring that part of the workflow. And in about 7 minutes, we'll come back and wrap this up. We may go about 5 minutes beyond the top of the hour just to finish things off and give you a chance to ask any final questions before we depart for the day. Okay, welcome back from your GCP Workload Identity Federation exploration. Let's walk through this final piece to the puzzle. So we're going to follow the same pattern as AWS, where we retrieve a token from the instance metadata service and use that token to authenticate or impersonate a service account inside of Google Cloud to get access to that same Google storage bucket file that we pulled down inside of the AWS walkthrough. So in order to do this, the first thing I wanted to show you inside of a Google Cloud project is in the IAM service. So if you browse to IAM and then go to the Workload Identity Federation section, what you'll notice is you have one in there called the Azure Cross-Cloud IDP. And if you open that up and go to the providers, you can hit the edit menu on this provider. What you're going to see is the same set of data. We're again trusting the identity provider in your Azure Active Directory tenant. And we are also requiring that the Nymeria workshop audience be set. We're also parsing the subject into a custom attribute called the Google.subject, which is going to make that subject again available to filter. Now, if we go back a screen and look at the connected service accounts, we'll see that we've got one service account here called the Nymeria Cross-Cloud Service Account. And that is being restricted to the Google subject of that 94C0 value, which is the unique identifier for my Azure virtual machine. Very similar to AWS, if you forget to set this filter up, any token from the entire Active Directory tenant with that audience can impersonate this service account. So it's very important, again, to make sure you've got that subject filter in place to restrict access. With that set up, we can go back to our Azure virtual machine and take a look at a cross-cloud client configuration JSON file that our Terraform deployment set on the VM for us. Now, there's nothing secret about this file. All it tells the G-Cloud command line interface about is where that identity pool is and what service account we're trying to impersonate. So you'll notice the very first thing we've got in here is the actual token URL, which is going to be pulling the credential source. Notice that link is the same. So you got 169.254, 169.254, which means that when I run the command with this file, it's going to grab the JWT from the metadata service, and notice the API is the Nymeria workshop. So that's how that token is going to get pulled. It's going to take that token and send it to the token URL, which is at stsgoogleapis.com. And in return, in exchange for the JWT, it's going to receive a OAuth bearer token from Google's STS service. You can then take that bearer token and pass that to this URL, which is at IAM credentials, and we can impersonate the service account with that bearer token, and we'll receive back a different bearer token that allows us to read the object from Google Cloud Storage. So all you had to do is run gcloud auth login with that credentials file, and you will get automatically logged in using the JSON web token. We can then use that OAuth bearer token to run the gsutil command and copy that object down from Google Cloud Storage. That completes our cross-cloud identity workflow from an Azure VM into a Google Cloud project. As we wrap things up here, just a couple of other items I wanted to mention to you before I jump into the closing remarks. When you're all done, make sure you do the last step, which is the teardown instructions. Keep going if you're not quite done with the workshop. I know we condensed this into a pretty small time frame. When you're finished, go out to your Azure subscription and you can run the teardown instructions for Azure from the shell. You can then run another set of commands in the AWS Cloud Shell and another set of commands in the GCP Cloud Shell to kill all those resources off. And then finally, if you want to, you can delete your forked Nymeria repository. So that will finish the workshop steps for you. If you thought this material was valuable, we've got a number of upcoming Sec 510 runs at various SANS conferences that you should definitely check out. There's a full deep dive into Workload Identity Federation with more detail on how to do other cross-cloud authentication, for example, from Google into Azure or from Google into AWS and so on and so forth. There's a live online run in November with Brandon Evans. Ken Hartman is also teaching a run in Austin, Texas. And we've also got our Cyber Defense Initiative, which is in Washington, D.C. in mid-December. So hopefully we'll see you at one of those events in the future. And with that, thank you for attending the workshop. I'll be around actually for the majority of the day to answer questions, or if you've got places in the workshop that you get stuck in, just post them in the Discord channel and I'll be able to answer that question there. Have a great rest of your day and thank you for attending.
And for all who are wondering, yes, a recording of this will be available in your SANS portal in about 48 hours. Thank you all for attending.